Okay, guys, notes out, please. I know the bell hasn't gone, but by the time everybody's notes are out, it's going to have rung, and I will want to start. See? Now, normally I would open the day with, did anybody have any problems with their homework, even on a short day? But I realized this from first block today. One of the questions I assigned to you, you could not do because I haven't taught you what slope is yet. Normally, the notes that we did half of 2 days ago, I would have gone and done a little bit more with. But we had the time, there was a time constraint. So, you couldn't do number 13. I know that you all did 5 and 9 and had no problem with it because it's easy. But you tried to do 13 and probably didn't get it. So what's going to happen is after today's lesson, you're going to go back, you're going to do 13 from page 384, and you're going to do the other stuff that's assigned today. Okay? All right. Now, normally I explain this box first. But again, that causes us to get into all kinds of trouble because you don't know what we're talking about. Many of you are better when you see a picture. So we're going to go ahead and we're going to use these 4 things first. Okay? You don't have these notes, Peter? You don't have them? They're on top of the microwave. My lovely assistant Preeti will hand them out.
Sir, let me give you box and pens.
Yeah. If you need these notes, put your hand up. Preeti will bring you a copy. Peter and Felix need them, I think. Peter and Felix. You got those? Oh, okay. Alright. So, we're going to start with these pictures. So forget about this box for a minute. We're going to start with these pictures. Okay, is everybody cool? Alright. So, this picture here, you have to envision, because I don't want to draw it in here because it gets too busy. Pretend, and I'm going to draw it, but I don't want you to draw it. Pretend that it's on a graph. Is everybody cool? Okay. Okay, don't draw it because I don't want to draw it because it'll get too busy. Everybody good? All right. Now start drawing what I draw. Here is point A. Here is point B. All right? If you had to direct me from point A to point B, but you didn't have this line here, and it was on a graph, how would you tell me to get there?
You would tell you the coordinates?
The X's and Y's, yeah? So, I would have to go up on the y-axis, and this way on the x-axis, yeah? And because both y and x changed, I ended up with an angled line. Everybody cool? Great. Up is what? Positive or negative? Positive. Excellent. Right is what? Positive or negative? Positive. Everybody cool? Everybody good? That's X and Y. Now, in real life, with a real life example, pretend this is a distance time graph. What's on the y-axis? Distance. And what's on the x-axis? Time. Everybody cool? Okay. What measurement do we use in real life that compares a distance to a time?
Miles per hour.
Miles per hour. Speeds. Right? Right? And we all remember from our last unit, on a distance time graph, the steeper the line, the faster it's moving, yes? So there must be some relation between this change, and this line, correct? That relation is called slope. All right? And you all know the word slope from skiing and snowboarding. It just means a downhill. When we say a slope, we mean a downhill in English. In math, it has other meanings, but we're going to stick with that. Now, you guys are smart kids. What if I have to get from B to A? And you're not allowed to go on the black line? What would you say? Alicia? You would go down on the distance scale, which would be what? Minus. And then you would go left on the time scale, which would also be minus, yes? Now, when we write a speed, as Josh said, how do we write it? What does it look like in letters if I were to write the speed 80 kilometers an hour? What do I write? 80 km /h. What does that slash mean in math class? Divide. So my speed must be a distance divided by a time, correct? Now, if that works when it's distance and time, and that gives me this slope, then will it work when I have x's and y's? Of course it will, because x's and y's are just another name for distance and time, yeah? So, if I go this way, I had a positive distance, and I divided it by a positive distance, correct? What will that answer be? Positive. If I go this way in red, I have a negative answer divided by what? Negative and negative, which gets me what? A positive answer. So if my line looks like this, I have what we call a positive slope. Everybody cool with that? Now you guys are very smart kids. I know sometimes you don't feel that way, but you are indeed. A, B. Now get me from A to B. Where am I going to go? Right, which is what? Positive. And then what? Which is what? Negative. Okay. So I would have a positive, I would have a negative up and down divided by a positive, which would give me what for an answer? A negative. Okay. Now go the other way. What happens if I go down here? I have a negative again, and if I go this way, I have a positive to get me what? Another negative answer. So what would you call this kind of slope? A negative slope. Everybody cool? All right. Now, look closely at these two special lines. Get me from A to B. It is either up. Oops, I shouldn't have done it in blue. It is either up, which is what? Positive. And how far did I go sideways? I didn't. Or it's down, which is negative. Did I go sideways? I didn't. So this would be a positive divided by 0 or a negative divided by 0, wouldn't it? Is that allowed?
Not for slope.
Not for anything. Can you divide by 0? No, because the answer is infinity. It doesn't exist. Right? So this is what we call an undefined slope. Because you can't divide by 0. If you try it on your calculator, it's going to say error. Go ahead, Bryce.
Do it.
I know you are.
Yes, but I still want to do it anyway. Jamie can't divide by 0.
Can't divide by 0. Why?
Because you can have
What happens to the number? It doesn't disappear. It just gets impossibly large, yes? What's 1 divided by 1? 1. What's 1 divided by 2? A half, right? What's 1 divided by a quarter? 1 divided by 4, a quarter, right? So I'm going to show you guys this. If I have 1 divided by 1, it's 1, correct? 1 and 1 on a graph, yeah? What's 1 divided by 2? So when I go out here to 2, 1 divided by 2 is half, so it's going to be right there, isn't it? Agreed? Then it's going to be a quarter, then it's going to be an eighth, then it's going to be a 16th. Is it ever going to get to 0? No, because you can always cut it in half again, correct? So this way is easy. Everybody understands that. You're never going to get to 0 cutting in half, are you? What happens if I go this way? What is 1 divided by a half? That's 2, right? So if I'm at a half, I got to be up at 2, don't I? What's 1 divided by a third? How many thirds fit into 1? 3. So I'd be up at 3 when I get to a third. Fourths, 4. Fifths, 5. Right? So what's happening to this line? It's going up, up, up.
I'm aware.
Will it ever end? No. Right? That's why it makes a graph that looks like this, and it never hits 0, and it never hits 0. Cool? It's for later math, but you just have to believe me that you can't divide by 0, so this is undefined. Now let's go to this one. How do I get from A to B? Which is positive. Or you go left, which is negative. Right?
Same thing.
No, it's not.
Isn't it?
No, it's not. Because this one would be 0. Notice we always put the up and down first. What's my up and down here? 0 over a positive or 0 over a negative. Can I divide 0? We already know I can't divide by 0, but can I divide 0? Of course you can. I have 0 pizzas in my hand. You want half? How much you getting? 0. You can divide 0. But you can't divide by 0. So this is what we call a 0 slope. Which makes sense, doesn't it? Could you ski on this slope?
Yeah.
If you had poles, yeah.
Only if you had poles to push yourself along, because there's no hill, is there? Could you ski this slope?
Yeah.
No. That's called falling. Because it is infinite. Okay? Everybody get the difference? All right. Now we're going to talk about what it actually means in math. Okay? Now you guys remember just last day we had a function, didn't we? It's right on your sheet. It was g of x equaled 1/2 x minus 2, right? It's just up above on your notes, isn't it? Was it minus 2 or plus 2? Excellent. Now you guys are also aware that this in the 9th grade was y, wasn't it? Okay? So we could rewrite this function as y equals 1/2 x minus 2, couldn't we? Everybody agree? All right. Now have a look at this construction right here and this construction right here. Are they the same? They are, aren't they? There's a y, there's a y. Or an output. Right? Doesn't have to be y. It could be c or d, couldn't it? There's an x, there's an x. We cool? Okay. Do we know what x and y are? Where do we find x's and y's? Where do we find x's and y's? In math class, together, living together in perfect harmony. On a graph. Lovely. So you know something about x and y here, don't you? Right? They can be on a graph. Cool. What's that? B. It's just a number, right? Do I have that over here? I got a number. So I know something about that, don't I? What's the only thing that doesn't make any sense? M and M. Because what is that? That, ladies and gentlemen, is the slope. Okay? Everybody cool? Now, we know from this drawing that a slope is a mixture of a rise and a run, don't we? Because if I don't change both of them, I don't get a slope, do I? Because here, when I only changed one, did I get a slope? Nope. And here, when I only changed one, did I get a slope? Nope. So I got to change them both. So the slope is rise, which is a measurement up and down on a graph, and then I divide that by my run, which is a measurement horizontally on a graph. Now here's the biggest mistake you guys make. You think that slope is a distance on the line. It is not. Slope is the comparison of my change up and down compared to my change left and right. It is not a distance. Okay? It is a combination of two distances. How far I went up and how far I went sideways. Is everyone okay with that? Everyone is good? All right. Now, so slope equals m. Now this is something that is also problematic for kids. It's always m, even though it's got a lot of different ways to be found. You know one way to find slope. I just explained it to you. What was it? Count up and count sideways. So rise over run. Right? And we can get that right from a graph. That's one way to find slope, yeah? Right.
Would you simplify it if you could?
Yes, of course. Yeah, we'll talk about that today anyway. So that's one way you could find it, yeah? You can look on a graph, just like we just did. I went up, then I went over. Right? Right? Do we have another way that you and I can work our way around a graph without actually having the graph?
Like the algebraic surface?
Yeah, the x's and y's, right? If I want you, I'm sitting still right here. So what spot am I on the graph?
0.
0, 0. Is there a graph around me?
No.
No, but could you move me now?
Yes.
If Bryce were to give me two numbers, would I know how to get to them? Yeah. Would I need a graph? No. If Bryce said 3, 1, where would I go? Which way would be 3? That way, because Bryce is the one telling me, right, Nick? So I'd go 3 that way and then where? 1 that way, because 1 away from Bryce. And I would end up over there by the board. Everyone agree? Was I able to do that without a graph?
Yeah.
Yeah. So I can also do this using coordinates. X's, oops, rise, y over x. right? Now, I'm going to give you guys a little fancy thing here. What did y and x both have to do to get a slope? They had to change. So we're going to add a symbol right here, and I'm going to add it in red. It's just a triangle. That triangle is a Greek letter, delta. And it just means change. Okay? Now, you guys are smart kids. What if my graph isn't x's and y's?
What do you mean? It's always X and Y.
D and T.
Then it's
So it's not x. Yeah, D is x. So it's also the change in dependent variable over the change in independent variable, yeah? Everybody so cool with that? Everybody good? All right, we're going to stop there because that is as much information as you need to do what we need to do today. Everybody cool?
But you can't ever have a graph and it not have like the X.
No, because the x's and y's just get a different name.
Yeah.
But Vanessa, you have heard people in this room say, Mr. Myers, I can't do that question because it looks different. Right? That's what I'm fighting against.
What if the graph has a z coordinates?
Graphs do have z coordinates. That's how you graph three-dimensional things.
Yeah, but like, does the math just completely just...
Yes, it changes significantly. All right, so you guys are smart kids. A, I'm going to do with a black line, okay? I got to think about that. Now, you guys have seen this. Please write this up at the top. Y equals mx plus b. You've got that written right here, yeah? Okay. You already know what y is. That's a coordinate on the graph, yeah? That's a y coordinate. You know what x is. That's an x coordinate, right? You know what m is. That's the slope, which is rise over run and all those other things. What's the only thing left? B. We don't know what B is, do we? But you do know what B is, okay? I want everybody to put down their pencil for a second and look back at this in their notes. It's right above where we were just working. I wanted you to find the intercepts, didn't I? Right? And the intercepts are 0, y, and x 0, correct? You remember this, right? You don't need to write this down. You've already written this down. Everybody cool? Okay. X's and y's. In this question right here, that is the y-intercept, isn't it? Right? Everyone agree? Everyone agrees? Okay. And I'm dealing with this function. Yeah? Because we've changed the g of x back to y. Everyone agree? Okay. What goes in for x? 0. 1/2 0 minus 2. What happens to 1/2 0? Turns into 0, so it drops out, doesn't it? What's left? -2. So y was -2. Does everyone see that? Is this in the form of this? It is, isn't it? We proved that right here. And we proved that the y-intercept was -2, didn't we? So if that happens once in math, how often does it happen? Always. So now, what do we know that b is automatically? The y-intercept. Is everyone cool with that? If you don't believe me, look. y equals mx plus b, correct?
It's frozen.
Everyone agree? We know that the y-intercept is when x is 0, yes? Right? So y is going to equal m times 0 plus b. What is m times 0? What happens to it? It disappears. So y is going to end up equaling b. The y-intercept is b. Does everyone understand that? Okay. So, using this first one, do you know the y-intercept? What is it? It's negative 4. Because if I make x 0, it's going to drop out and the answer is going to be negative 4, isn't it? So I can put a dot at y equals negative 4, can't I? Now that dot isn't a line, is it? It's just a dot. But I can make a line, can't I? Because I also know the slope. What is it? 2. So for this one, m equals 2. What's 2 really in math if math guys weren't lazy sacks of crap? It would be 2 over 1, wouldn't it? And isn't that a rise over a run? Isn't it? Because m equals slope, slope equals rise over run. So doesn't that mean I'm going positive 2 up and positive 1 right? And I start from here. So I go up 1, 2, and I go 1 to the right. Where's the next dot going to be? Up 2, 1 to the right. Where's the next dot going to be? Up 2, 1 to the right. Is Bryce neglecting anything? Yeah, because this line goes in both directions, doesn't it? So couldn't it also go down 2 and 1 to the left? And down 2 and 1 to the left? And down 2 and 1 to the left? Would I connect that line?
Yes, because they're just numbers.
Yes, because they're just numbers. And how long will that line go? Forever and ever and ever and ever, to quote iCarly.
You remind me like a little turtle. Because of your head.
I will remember that, Vanessa. Everybody cool?
Yeah.
So you should be able to do the rest of these, shouldn't you? I'm going to work in red for B. Who would like to tell me where to start? Go ahead, Bryce.
Alright, so it's negative 1, which is the slope, because it's negative x, and it just be the base of 1. So that would be 1 over 1, and it starts at positive 1.
So I got to go to positive 1, because that's my y-intercept.
Yeah.
And then I need a slope of negative 1, yes?
Yeah.
So I have to go up and left to get a negative, or down and right to get a negative. And how long will that line carry on for? Ever. So if I go down 1, over 1, down 1, over 1, down 1, over 1, or up 1, left 1, up 1, left 1. And that line will go on forever, won't it? Everyone agree?
Yeah.
Is everyone cool with what we've done so far? Okay. Now, look at H. H is tricky, but it's not, is it? Where do I start? At the y-intercept, which is what, Vanessa? Positive 5. So I go up 1, 2, 3, 4, 5, and I put a dot. What's my slope got to be? Negative 1/3. Now, negative 1/3 must mean a negative rise over a positive run, correct? Or a positive rise over a negative run. How far up do I need to go? If I'm going to do the positive rise first, where would I go? rise. Where would I go? Up 1. Yeah. And then where do I go for my run?
To the left.
To the left. How far? 3. 1, 2, 3. And I put a dot. Where do I go if I go down to start? 1, 2, 3 over here. So I have a negative and then a positive. Or a positive and then a negative. And then what do I do with that line? It goes on forever. Is everybody getting the hang of this? Is everybody good? Okay. Now look at D. Does D have a y-intercept? No. There's nothing there. What number in our system represents nothing? 0. So the y-intercept must be what? 0, which is right there. Yeah? What's my slope? What is the number that should be right there, but math guys are lazy? 1. And what should 1 really be over, but math 1. So my rise and my run must be 1. Up 1 over 1. Up 1 over 1. Or down 1, left 1. Down 1, left 1. And then what do I do with that line? I can connect it because it's just numbers. Does everyone see how it works? It's pretty easy, yes? Everyone is good? When it's in this form, you always know how to graph it. You don't need a table of values anymore, do you? If we were in grade 9 and I gave you this, y equaled 2x minus 4, how many of you would have gone, okay, x, y, negative 1, 0, 1. 2 times negative 1 is negative 2, minus 4 is negative 6, negative 4. 1 times 2 is 2, 2 minus 4 is negative 2. How many of you would have done that?
I thought you just take away or add from each side and then divide.
You all saw that in the 9th grade, yes? Do we need to do that anymore? No, but only when it's in this form. So describe this form to me. What are some rules about that form?
What you take away from one side, you have to do
Y alone.
Right, that's what I mean. Not what we're going to do with it. What does that look like? So step 1, y. Is it always going to be a y?
It might be G of X.
It might be g of x. It might be c. It might be d. So y, and when I say y, I really mean the output, right? Yeah. Your output is isolated. And is it positive or negative?
Positive.
Positive. Your output is isolated and output is positive. If your output is isolated and positive, then you can do what we just did. Go to the y-intercept and count your slope, and then you can graph it. Everything. Bryce.
For C, I'm not sure how you got that line, because you did negative for x rather than y.
So the negative can be on the top or the bottom to get a negative, right? So I either went up 1, which is positive, and then that way 3, which is negative.
Wait, so you did y first then?
Yes, rise first, always, because it's rise over run.
For some reason I got that backwards. Alright, good.
Everybody cool? Is everybody good? Everybody understands these two things? Yes? Okay, so let's do some work with those lines. I need the f of 2. So what color line of mine is the f line? Is it black, red, green, or blue? It's black, right? So the f of 2 is a black line, yes? Now, that 2 is what? It's an x, isn't it? So I need to go on my line, my black line, and find where x equals 2. It's right there, isn't it? What's my output? 0. So the f of 2 equals 0. Everybody cool with that? From the graph. Everyone agree? Can I do it algebraically? Yes. In algebra, it's the f of 2 equals 2 times 2 minus 4, correct? Because x is now 2. It was 2. I'm explaining that right now. The x is now a 2, correct?
Yes.
And this, according to our function, was an x. So if this x is 2, what is this x? 2. 2 times 2 is 4. 4 minus 4 is 0. Can everybody find something using the graph and algebra? Everyone is good? Great. Do the next one. What color line am I using for H? Blue, red, blue. So what's the x value that I care about on the blue line? Here. 3. So on the blue line, I got to go to where x is 3. Where's x is 3?
Down.
X is 3. I need x to be 3. So do I go down or horizontal?
Right.
Right. 1, 2, 3. Because I need positive 3, yes?
Yeah.
And then I need to find the y that's on the blue line, correct? So I go up, and what is it?
4.
4. Everyone agree? Okay. So that's finding it on the graph. It equals 4. Can I find it algebraically? Yes. I don't want the h of x, though. I want the h of 3. So what do? Negative 1/3 times what? 3 plus 5, right? Well, what's negative 1 times 3? Or negative 1/3 times 3? What do you do with the 3's? Cancel, so I'm left with negative 1, yeah? What's negative 1 plus 5?
Or positive 4.
Positive 4. So now we can find them on the graph and algebraically, yes? Okay. The next one, g of x. What color is g of x?
Right.
It's the red line, correct? Okay, now, wait a minute. I don't know x, but what do I know? G of x, and g of x is also our y, right? So, if I know my g of x is 4, I also know my y is 4, correct? So where do I go to get to y is 4? Up. How far? 4. 1, 2, 3, 4. Now I need an x for there, don't I? On which line? The red line. So I slide over, and what is it? Negative 3. Everybody good? So my x value equals negative 3. Now, my honors kids, a bunch of them screwed this up on their test that they just wrote. What's the function for g of x? It's negative x plus 1, correct? So I write it out. G of x equals negative x plus 1. Right? What do I know? If I didn't have the graph, do I know that x is negative 3?
You can actually algebraic.
I have to do it algebraically. I know g of x is 4, so what goes here? Does the 4 go just for the x, or does the 4 go for everything? Where does the 4 go, Alicia? Everything. So this is 4. And what does 4 equal? Say it.
Negative x plus 1.
Plus 1. Now I solve it. Right? That 1 goes where? Over here, and what happens when it hops over the equal sign? Turns negative. So now I have negative 1 and 4. So what's that answer? 3 equals negative x. Is x by itself yet? No, there's a negative there. So that negative has to come over here, doesn't it? And what does it become? Negative 3 now equals x. And oh look, it did. Even when we did our graph. Is everyone good graphing and algebra?
Yeah, what I accidentally did wrong, I read it because I assumed that for some reason I read it backwards and I put the 4 as the x. It still gives you the same answer.
That's a big problem. Right, Bryce? Because if you didn't catch that, you're going to think that's the way to do it if you don't pay attention to me. Because sometimes you will get the same answer even when you do it wrong. And then you think you're okay. Everybody cool? Everybody's good? All right. Now, I'm going to give you a fair warning here. I want to show you something. I'm going to write out an equation here, and I'm going to ask you if you can graph it without using a table of values. Okay? You can talk to your neighbor. I just want to see if you can do it. Could you graph that without a table of values? How? How would you graph that without making one of these? By doing what to it? Talk to your neighbor. Think about it. How are you going to solve it algebraically? I'll give you a real big hint. If it looks like that, can you graph it immediately?
Yeah.
Can you make this look like this? How? What are the differences? This is what you want. This is what you have. Can you get this to this? How? Brad, give me one first step. If I move this y over here, will he be positive? And we want a positive y, don't we? Okay, so let's do that step first. 3x plus 12 equals y, and then I had a positive 16 here, didn't I? Because that was already there, right? Okay, are we here yet? What else do we need to do? I want to get y alone. Y is already positive, but he also needs...
16.
I need to get rid of that 16, don't I?
Yeah.
So it becomes minus 16. Did I do anything to the x?
Not yet.
3x. What's 12 minus 16?
-4.
Negative 4 equals y. Could you graph that right now?
Yeah.
Where would you go to graph that?
You put the 3 on the x.
Where do you go? We just graphed it 4 times from an equation. Where do you go? Guys, we just graphed it 4 times. Where do you go? It was literally 2 seconds ago. Where do I go? Negative 4 on what? On the y's or the x's? Why? Because isn't the number by itself the y-intercept? So I go down to negative 4. Now what do I do? Up how far? 3, which takes me to negative 1, and then where? It's rise over run. What's this number got to be? 1. So I go up 3 and over 1. That point is negative 1, isn't it? And this point is 0, negative 4. What do you get to do with those 2 points? You connect them because they're a line. Where's the next dot going to be? Up 3 and over 1. So up 3 from negative 1 is going to be positive 2, isn't it? And over 1 from 1 is going to be positive 2, isn't it? Where's the next one going the other way? Down 3 to negative what? Negative 7. And this way 1 to what? Negative 1. Does everybody see how to do it?
No, I don't get, after you went to 0 and negative 1, how do you get that?
By following the slope. Slope is rise over run. I went up 3 over 1, up 3 over 1.
Did you get over 1?
Because every number in math is always over 1, Josh. So that is a rise divided by a run. Got it? So now, even if it doesn't look right, can you graph it? You don't need a table of values. You just need to move it around. And you already know how to move things around because you've been doing algebra since the 3rd grade, even though nobody called it algebra. Everyone cool? Yeah? Okay. I think you're lying to me a little bit. I want to do one more. I don't want you to write it down. Pay attention. 4x plus 3y minus 6 equals 12. Graph that. Is it in a form that you like to graph? No. What is the form that you like to graph? That you can graph like that without a table of values. What must it look like? Y equals mx plus b. Make this look like this. What moves? Why would I move the y over? It's already positive. So I'm not going to move the y because the 2 things that y must be is alone and positive. It's positive right now, yeah? So what is it not? Alone. So I better move everything else, yeah? So when this guy moves, what happens to him? 3y minus 6 equals negative 4x, and there was already a plus 12 there, correct? Excellent. Now what has to move? The 6, because y's got to be alone. 3y, that 6 is going to become what? Positive 6. So I'm going to have negative 4x. What's 12 plus 6? 18. Is y alone yet? No. What gets y alone now? Divide by what? 3. They're going to cancel. Is y now alone? Awesome. But what do I got to do to this side? Divide. The 18?
With x.
And what else?
And the x.
And the 4. So I'm going to have negative 4 over 3x plus, what's 18 divided by 3? 6. Is that in the form you can graph?
How did you get negative 4 over 3? You just left
Negative 4 divided by 3.
just like that.
That's what it means.
You said you know what? No, but I just didn't.
Now, where do I go to graph that? Where do I start always?
Or 6?
6 on what axis?
Y.
The y-axis. So I go up to 6. Now this graph isn't scaled, is it? So I got to label that guy as 0, 6. Agreed? Now I need a slope of negative 4/3.
So then you put the 6.
It's rise over run, correct?
Yeah.
So where do I go from here?
You go down.
Down 4.
Yeah.
So my 6, I'm going to go down 5, 4, 3, 2, correct? And then where do I need to go?
Right 3.
Right 3. 1, 2, 3. What's that point going to be?
1 and
Not 1,
3.
3, 2. because I went down 4 from 6 to 2 and a positive run of 3 from 0 to 3. What else could I have done? Could I have gone up? To what? 10. And this way to what? Negative 3, 10. Would have been up here. And then I could connect the line. Does everybody see how to do it? So now, with your grade 8 algebra skills and your grade 10 knowledge of, oh, of course, if x is 0, that's obviously the y-intercept, you can now graph any line as long as it's in that form as soon as you see it. Correct? Everybody good? Okay. You have number 13. You can do it now. And that for homework tonight. 5 questions. I'd like to pretend that all of you are going to have it done tomorrow. I still live in that world of make-believe. Nothing. You will have the prize of knowledge that will help you for the rest of your life, Andrew. It will allow you to be less stupid than the people around you, which is the best price you can get.
You sound like Sheldon.
I know I sound like Sheldon, because Sheldon is right. Smart people succeed, and you get smart by learning more knowledge.